Welcome back, everyone, to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a paper called Two Heads Are Better Than One Test Timescaling of Multi-Agent Collaborative Reasoning. It tackles how to make multiple AI agents built on large language models work together more effectively on really complex problems. The researchers propose a framework that not only trains models specifically for collaboration, but also adds a sort of CEO agent to manage the team's discussion and reasoning process. They show this approach really boosts performance on tough tasks. Okay, so Figure 3 here gives us a nice visual of how this CEO agent fits into the picture. You can see the typical multi-agent system flow at the bottom, starting with an expert recruiter, then moving to problem solvers and executor, and finally, an evaluator. But now, sitting above them is the CEO agent. It takes input from the whole system, like suggestions on experts needed or confidence scores, and then makes key decisions. It decides whether to continue or stop the process, how many agents or experts to recruit, what the focus should be, and even how many tokens. Basically, how much thinking power each agent should use. It's really about adaptive management. Okay, so how much does this CEO agent and the special training actually help in practice? Well, Table 1 here gives us the breakdown. It compares different models, including their M132B model, both with and without the CEO, across tasks like general understanding, math reasoning, and coding. You can see their M132B model, especially with the CEO, consistently outperforms the original QN 2.5 base model it was built on. For example, on the AME math problems, it jumps way up. And importantly, adding the CEO on top of their fine-tuned M132B model provides another consistent boost across all tasks shown here. So this really demonstrates that this specialized training and that adaptive CEO management we just talked about make a tangible difference in performance. And speaking of the CEO agent's value, Figure 4 gives us a concrete example of this, what the paper calls an aha moment. Here, a problem solver agent makes a mistake in its calculation for a geometry problem, resulting in a negative length which obviously doesn't make sense. The CEO agent, powered by that M1 model we discussed, actually catches this. It points out the error, suggests re-examining the geometric setup, and decides to continue the process with specific parameters like token limits. The problem solver then incorporates this feedback and gets the correct answer, so it's not just managing, it's actively correcting the reasoning. Okay, so building on that idea of collaboration in the M1 model, Figure 5 explores how scaling different parts of the multi-agent system itself impacts performance. Using their M132B model again, they looked at changing things like the number of critic feedback rounds and the total number of agents involved. We can see that more critic iterations, more feedback loops generally help improve accuracy. And adding more agents helps too, but interestingly, only up to a certain point, after which performance actually drops. It suggests there's a sweet spot for team size, which reinforces why having that adaptive CEO is useful. Okay, so building on that idea of scaling, Table 2 here gives us a really interesting comparison. It shows how the base QN model and their fine-tuned M1 model perform when working alone as a single agent versus within the multi-agent system, and then with the CEO agent added. What's striking is how much the M1 model benefits from the multi-agent setup. Its scores jump significantly on tasks like AME when moving from single agent to the team. The base QN model, well, it doesn't get the same boost, and adding the CEO consistently pushes the M1 model's performance even higher, further highlighting that the specialized training really helps it leverage that collaborative structure. So, speaking of scaling and resources, Figure 6 looks specifically at the impact of scaling the reasoning depth by controlling the maximum token usage allowed for each agent's response. We're again looking at the M132B model. The plots show accuracy on AME math problems and GPQA general questions against the maximum tokens allowed. You can clearly see that for both tasks. Allowing more tokens, basically giving the agents more room to think, leads to better accuracy. This really underlines why that adaptive CEO is so important. It can adjust these token limits depending on the problem, optimizing performance. So, pulling all these scaling insights together, this paper really highlights the potential of multi-agent collaboration for boosting AI reasoning. We saw how their specialized M1 model thrived within the team, especially when guided by that adaptive CEO, who could adjust things like, well, team size and reasoning depth dynamically. It really suggests that engineering these smart collaborative systems, not just building ever larger single models, is a promising way to tackle truly complex challenges. Thanks for joining us on the AI Research Roundup. I'm your host, Alex.